Good evening, Sky people. I'm Molly, your host tonight, and you're watching the Astro Imaging channel. Tonight we have with us Andrea Girones, an astrophotographer hailing from the Great White North, Ottawa, Canada. She'll be telling us all about solar imaging, just in time for solar maximum, and not only in H-alpha, but also in white light and calcium K. But first, before that, a couple of notes. On the calendar next week, we ourselves will be doing some presenting on how to process all those gorgeous solar eclipse images that you've acquired. And we'll cover some topics like how to use smart objects in Photoshop, how to do HDR processing in PixInsight with Larsen Sekamina, and some other topics as well. Then the following Sunday, we'll be filling a gap in the calendar, and we'll be presenting again on some more topics. Probably talk about PhD guiding and a couple other topics to be determined. And at the end of the month, we'll have the venerable Robert Reeves come talk to us about the Lunar Orbiter imaging program that was done for the Apollo missions, which used film cameras and scanners on satellites in the 60s to scout for landing sites. And he's got a boatload of prints of those images, and he's going to talk about that program. So don't forget to subscribe so that you'll get notifications when we go live and what shows are coming up. And it will also help more people find our channel so that more people can hear all about all the cool astrophotography stuff that we have people on here to teach you all about. And also, don't forget, if you're looking for a particular topic that we've covered on the show, we've covered probably everything that exists over the last almost 10 years. We have a Google Sheets database on our website, and you can go search through that. It's got all of our programs from the last almost decade, and it's got descriptions all listed there, so they're searchable. And so if you're looking for a particular topic, then you can go look there to help you find it. And I think that's all the announcements that I've got. So as long as the show is actually running, then I'll hand it over to Andrea.
Thanks, Molly. Thank you so much for having me here. I'm looking forward to presenting on this topic. So let me just get my slides going. All right. Do you see it?
Yeah, looks good.
All right. Okay, so my topic this evening is solar observing and imaging. And as Molly indicated, we are approaching solar maximum, if not in the thick of it. And so it's a really exciting time to be doing solar observing. So I live in Canada. I live in Ottawa, which is the nation's capital. I am a lawyer. I'm not an engineer. I'm not a scientist. This is just my hobby. I do a lot of astrophotography, and I am published in several of the publications of the Royal Astronomical Society of Canada. And I normally image at night, and I was on a photography workshop, and I actually had to tell my instructor, I don't do daytime photography. I didn't know what to do. But then I started doing solar imaging a couple of years ago, and I wanted to share my journey from total newcomer to taking some cover-worthy images. And I hope it might inspire some of you to also try your hand at solar imaging. There are really a lot of wonderful benefits of solar imaging, not to mention the best fact is you get to sleep at night. Your family can't complain about how cranky you are because you didn't sleep. It's warm out. You have to wear a hat and sunscreen to protect yourself from the damaging solar rays. And I usually set up actually an umbrella. I enjoy solar imaging, and I'm going to talk a bit tonight about white light imaging, hydrogen alpha imaging. I have a Lunt telescope, and I also have a DayStar Quark, and they're quite different in how the results you get from them. And I also just started calcium K imaging. I'm also at the end going to talk about some new developments and some new tools and software that are available. And one of the things that I love the most about solar imaging is it's always changing. The sun changes daily, it changes hourly. Unlike deep space photography, where my Veil Nebula will look like your Veil Nebula, the sun is always changing. So this was where I spent April 8th. I was up in Quebec. We actually was so far north, we had a frozen lake. And the solar eclipse has really inspired so many people to try their hand at taking solar images with white light filters. And so this is one of the collages that I did from April 8th. My favorite part of this is the little baby diamond ring. But everybody, I think, has gotten sort of a feel for taking filtered solar images since this past April. This was another eclipse that I was able to image from home a couple of years ago. And also I was able to travel to Albuquerque last fall to do the annual solar eclipse. So we're all familiar with the white light solar filters, and I make all of my own filters. This is Beta paper number 5. I make all of my own filters. I have a roll of this paper, and you can just use any digital camera to take a picture of the sun. But the next step, if you want to take the next step in your solar imaging, you really need to learn a little bit about lucky imaging. And if you have ever taken images of the planet using lucky imaging, then you're going to have a bit of a head start here on the solar imaging. It's a technique for capturing images of bright solar system objects. So you take a video, and typically it's a video shot with a monochrome planetary camera. And we tend to shoot these images in monochrome, and we then either add false color to the sun or we use colored filters, such as what I was doing with my planets that you see here. Lucky imaging is critical because video helps you take really fast images, and that helps reduce the impact of seeing. Seeing is this pretty nebulous concept to do with the atmospheric disturbances and waves in our atmosphere. And when you see bad seeing, you understand what it is. And when you have good seeing, you understand what it is, but it's very hard to describe. But lucky imaging is our way of trying to reduce the impact of seeing. Once you capture a short video, you will use a stacking software like AutoStacker, and you're only going to stack the best 10%. Or 30% or 20%. Then you have a TIFF. You can then process that TIFF in the usual way with sharpening, noise reduction, and all of that. And for the sun, we are going to use very similar techniques and some unique software tools. So all solar imaging must be done through filters. And I'm talking about, in this presentation, it'll be filtered images with a telescope, solar filters, and I will be referring to planetary cameras. So planetary camera, it's unlike a deep sky camera, it doesn't have to be a cooled camera. They're pretty small. They have small sensors, which help the image scale get a little bigger. They are fast. They have a 3.0 connection. And my planetary cameras that I have 2 of them, the 290 mm monochrome, and I also have the 174 mm. The 290 has smaller pixels, and I like it with one telescope, but not others, and vice versa. If you are looking to purchase a planetary camera, Player One has some really cool ones that I recommend you also check out. I have my eye on the Apollo Max, but I don't have it yet. As you can see, they always come with a nose piece that you can just plop in to wherever you have your eyepiece holder, and there you go. You're ready to do your planetary imaging. A planetary camera does require a computer to control it, and you need software to run your planetary camera. I used to use Firecapture, which is a free software, and I still use Firecapture for planetary images. However, for solar, I use SharpCap exclusively, and I'll get into the reasons why I do that. I do know there are people who are now using their ASI Air as a computer to capture solar images, and I know TJ Connolly is using it extensively, and he's gathered some really wonderful images using the ASI Air as his computer with his planetary cameras. So these are, this is my white light setup in my backyard. As you can see, I hand make all of my solar filters, and they look pretty bad, and a kindergarten child could probably do a better job, but they work perfectly well on my front end of the telescope. And then at the back end, I just plop the planetary camera in where the eyepiece holder is, and I'm able to get focus. In these situations, I tend to use a diagonal. You can also, my preference is a threaded straight through connection, but for white light, I normally just use the diagonal. Oh, and yes, I have a cardboard box there where I do hide with my computer. So you do sort of need a bit of shelter so you can see your computer screen. My husband has eventually, he did make me a proper box to hide in for my solar imaging. So when you use white light solar filter and lucky imaging, you can get a lot sharper detail on the sun than you can with your DSLR camera or your mirrorless camera. You have a smaller sensor that allows you to get closer up. You're only stacking the best 10%, 20% of your lucky images. And so you can manage to get quite a lot of nice detail on the surface of the sun, which is the photosphere. You'll see sunspots. You'll see that granulation on the surface of the sun. And near the edge, you'll see this white granulation called faculae. And most of my white light images, I also use a green continuum filter, and that really makes a difference with white light imaging. You'll get much better contrast. The nice thing about white light imaging is that you can use your normal telescope. You can also use your eyepieces, and you can use Barlows to magnify your close-up look at the sun and the sunspot. So there's a lot of really interesting things you can do with a really inexpensive filter. Just a quick recap about what all these sunspots are about and what's happening lately. Over time, as a sun, on the left-hand image is an image of the sun in solar minimum, when things are very quiet magnetically on the sun. Over the 11-year solar cycle, the magnetic field lines get more and more tangled. And in the right-hand image, you're going to see once the magnetic fields get really tangled up, little bubbles and little loops are popping out of the surface of the sun, and that's what creates the sunspots. So when you're looking at the sun in white light, you are seeing the photosphere, which is the surface of the sun, and the sunspots usually represent the magnetic field lines that are loops that have popped out, trapping the hot air underneath. And so sunspots are actually cool areas. As we are approaching solar maximum now, we are having a lot of sunspots, and not just a lot, extremely complex, multi-spotted, reverse polarity, all kinds of very unstable magnetic sunspot groups, which is creating a lot of flares and a lot of solar activity. And the sun is changing from week to week to week. It looks different every day. Now, I don't do a lot of white light imaging, but this gives you some idea of what you can get with a relatively inexpensive setup. You can use your Barlow to zoom in and look at the edge. You can get detail in the dark parts of the umbra, as well as the penumbra of sunspots. So give white light imaging a try if you can. This is what a video looks like. So you're basically taking videos. This was a sunspot that I was trying to image, but I ended up not being able to stack this video because of all the cloud, but it turned out to be kind of a cool video of the sunspot just on its own. That was a really big one from last summer. Okay, I am going to move to H alpha telescope. So I don't know if there's any questions. I'm going to keep on going.
Yeah, we're still
Well,
here.
this is the 3 seconds it takes for us to.
I was having a drink of water, so I'm okay.
Although Patrick or Terry, whoever actually grabbed the stream, there was a request to make Andrea's picture-in-picture a little bit larger.
Somebody wants to snoop into my back of my room here. Okay.
I don't know.
All right. So now
there's a number of comments. I don't see. No, I guess we're all set for now. Just a lot of commentary so far. So
okay.
Back to you.
All right.
And
So now
Molly,
Yep.
I think that request, it just says, John wants to know, can we make Andrea a little bigger? He didn't say anything about her picture.
I need to eat more.
Yeah,
I
so
need
have
to
some
eat
dessert.
more. All right.
Anyway,
All right. Back
Patrick?
to the presentation. Okay, so we're going to talk about H-alpha telescopes because that's where things get a little more interesting. So I became interested in this little telescope after watching a video that Dylan O'Donnell did about, he called it the best new cheap telescope. And this telescope is the Lunt 40 millimeter, and it is quite a neat little telescope, and I ended up buying one. And you can see here it is. It's tiny. It's so small, and I had it in my carry-on baggage when I went to Albuquerque. It is 40 millimeter aperture. It is 400 millimeter focal length. And it's quite reasonably priced when you compare it to the Lunt 60, which is also a dedicated hydrogen alpha telescope. The Lunt 60 is also 400 millimeters, but it's a bit more robust and it has a different tuning system. It's pressure tuned. The Lunt 40 is tilt tuned. The Lunt 60 has a nicer focuser, but it's like 3 times the price. So overall, I thought this was a nice sort of introductory way to start looking at whether I wanted to even do solar astronomy. You can see that I have an eyepiece in this image, and I also have it on my Star Adventurer. So it's light enough to just go on the Star Adventurer. The Star Adventurer can track in solar mode. I can take it anywhere in my yard. I can have a cup of coffee on a Saturday morning and do a time lapse. And Lunt has just also released a double stack module, which you would screw on the front of the Lunt 40, and you would have what's called a double stack. And lots of people like to double stack the 2 etalons to get even more contrast with your solar images. So I love this telescope visually, and I'm going to show you how I used it to take images as well. So one of the nice things and why I think this is such good value is the scope comes with things that often you have to pay extra for, such as the mounting dovetail. It's a Vixen style dovetail, fits right into the Star Adventurer or any telescope mount. It comes with a Sol Seeker, which is a solar finder kind of thing. It's a way of getting the sun into your, I guess it's a finder scope, but it's not really a scope. The focuser is not so great, I will say that, but I tend to focus just by pulling the blocking filter in and out. That's how I focus. And as you can see, if you do deep sky, you probably have one of those little red cameras. They're a guide camera, and you could just stick it in into the eyepiece holder, and you could give it a shot trying to image, and you'll be in black and white. And it's a good way to start and see if you like this kind of stuff. I personally do use the ASI 290 planetary camera. And why I use the planetary camera, it has a 3.0 USB connection, very fast. I also do a threaded connection. I don't like just sticking it into the eyepiece holder because I do flat frames. And if there's too much wiggle, you will lose your flat frames, and we'll talk about that. I think the sampling of this camera and this telescope is incredible, and I think you'll agree when you see some of the images, but there is a little trick, and actually it was Wanda who helped me solve this little problem, who is a well-known imager. I'm just going to go back for a second. Take a look at the size of the black adapter that's holding the guide scope and compare it to this 60 millimeter adapter. In order to get focus with the 290, you have to get a shorter little adapter. So that's the trick. And then the other thing to realize is I have a B600 blocking filter, so I can only actually get half of the sun with the 290. So I do 2-panel mosaics, 2 panels. It's not hard to blend and merge. So I don't mind doing that. Some people like to have the whole disc, and for that you need a bigger sensor, like the 174, but I don't use the 174, and I'll talk about why. All right, so as you can see, I get really nice sharp details with the 290 and the LUNT 40, a 2-panel mosaic. No big deal, it's not too hard for me to put them together. You do want to try to, the sun changes so quickly, you want to try to do your 2 panels like really quickly right after each other, because the sun will change in a matter of minutes. So this is was a little time lapse that I did with the LUNT 40. This approximates the field of view you have with the 290. I think I'm cropped a bit on one side. I can usually get the full top half. And what I love about the LUNT, and most LUNT scopes that you see will have great detail in the chromosphere, which is the surface. This image was processed inverted. So when you see some black areas, those are actually little flaring areas. And the LUNT also has very nice prominence detail, something that's a little trickier with the Quark, and we'll get that. But, I'm pretty happy getting these kind of images with that little telescope and my little planetary camera. Okay, next. Okay, so yeah, so I also did, sometimes I only use the 174 when I want a full disk. The 174 does not have the nicest sampling with the 40 millimeter LUNT. You'll see that it's not quite right when I do a close-up, but when I did the annular eclipse, I shot the annular eclipse totally in H-alpha, and it lends itself to that because the sun never totally fades away. But I didn't want to be bothered doing a 2-panel mosaic in the middle of an eclipse, so I just used the 174. And that's what it looks like close up. It's not quite the same sharpness that you saw with the 290, but for the eclipse, it was exactly what I needed. And so I think I went a year and a half with the LUNT 40. I was very happy with it, but as often happens in this hobby, I wanted to go deeper. I wanted to get more detail. So I researched this and I decided to go and get a Quark. Now, and get really close up, because some of you may or may not know, the Quark is a solar filter that goes in the back end of your telescope assembly. So the Quark chromosphere also has, well, I'll get to that in a second. One of the things you have to realize is the Quark, it needs an energy rejection filter. So we call those an ERF. So an ERF has to be used with the Quark. If you have 100 millimeter aperture or less, you don't need to have a front mounted ERF. You can just have an ERF in your imaging train. I'll just show you quickly because my next image, I'll just pop over here quickly. This is my Quark imaging train, and as you can see, just in front of the whole imaging train is a filter holder, and that's where I put in just a simple 2-inch UV IR cut filter. That is my ERF, the energy rejection filter. If you have a bigger telescope though, with like 120 millimeter aperture, you're going to have to buy a front end ERF. You have to do that to protect the Quark. You want an f7 refractor because that works best with a Quark. And what's really important is you really shouldn't use anything like a Red Cat 51, Red Cat 71, or any of those ASCAR 5-element refractors. Because if you don't have an ERF at the front end of your refractor, all that energy is going to be bouncing around through the 4 and 5-element refractors. So no fancy refractors. You want a doublet, an inexpensive doublet for quarks. Now, there might be some exceptions to that rule, and there's some special quarks for Schmidt-Cassegrains, but they also need a front-mounted ERF. All that to say is the 102 millimeter refractor that I had is basically the biggest refractor I could get without having to buy a front-mounted ERF.
Andrea,
And this is, oh,
can I
yes.
ask you a question? This is a discussion that we are having locally.
Oh,
And are you comfortable letting all that energy for hours on end into your telescope, no matter what the size of the telescope? Because there's some disagreement about that. So whether it's a 102 or a 60 or 130, all that energy is going to go inside that tube and heat it up. And if you put your ERF in the back, you still have a lot of energy in your scope.
yeah, you do. And so I don't think I would want it, like, maybe you don't use a very expensive scope. And that was one of the recommendations I had. Don't get a very expensive scope. You don't need it. And maybe it's dangerous. I don't know. I do know that front mounted ERFs are really, really expensive. And that's why people maybe don't get them. It is almost cheaper to buy a new inexpensive doublet than buy a front mounted ERF.
I would agree with that. ERFs
Yeah.
are very expensive.
Yeah,
Big
they're
ones
very, so I've been using it. I don't think, and I still think my scope is doing a good job. I don't know if there's any damage inside my scope. Maybe I'll find out at some point, but I didn't put a lot of money into it. So, I mean, I hope that it would, I hope it would be okay. And that's, you know, that's what the Quark people have advised us, the DayStar people. I don't know.
Okay, thank you.
I don't have any strong views on that. I don't really have the engineering knowledge, but yeah, I would agree there's a lot of energy going in. But the other thing too is, how much time are you spending out there? Unless you're running a time lapse, you can do a lot of videos in a pretty short amount of time.
That's true, but if you're doing a long time lapse to see changes in a prom or in just a surface, you could be out there for hours at a time. Anyway, just wanted to add that comment. Thank you.
I'm gonna just have a little cough. Yeah, I do not have the answer to that. Although I definitely wouldn't want to have like a Red Cat refractor. I think that would really do some damage.
Andrea, while we're in a question break here,
sure.
Earlier Dean asked the difference between the 174 mm and the 224 MC. Is that a question that comes up in solar imaging? Or?
Well, the MC would be color.
Okay, not much other
so
difference.
That would be number one difference. The 174 has bigger pixels than a lot of the small planetary ones that only have a 3 point something, maybe even a 2.9 size pixel. The 174 has bigger pixels and has been considered better for lunar and solar astrophotography.
Okay.
But that would be the main, and it's a much bigger sensor, like it's a lot bigger.
Simon wants to know that, well, he just makes an announcement that you should remove the flattener or reducer for solar imaging. Is that along the same lines as removing the extra elements in a Petzl or not using it?
Yeah. You do not use your flattener. You do not want a reducer, at least not your deep sky reducer. I use a different reducer and I'll get to that.
Okay. That's all that's in the...
Yeah, no, you definitely don't want your flattener. You don't need it. You don't want it. None of that. I never did any deep sky with a refractor, so I didn't know about all those things and that they existed. So I just figured this out on my own here, kind of. All right, so back to the Quark. So the Quark can, there's a couple of different ways to attach it to your telescope. You can see on the right, you can just stick it into the eyepiece holder of a diagonal. And there's quite a few people who use their Quarks like that. If you go online and look at it, a lot of people do that. I decided to not do that and go for a threaded straight through connection because of the wobble. I didn't like wobble because I do take flat frames, and as soon as your imaging train wobbles, I would lose the flat frame. And I am starting to cough, so give me. Okay, and ignore the black big round thing at the bottom. That is actually was from a little experiment I was doing with a double stack with a Quark, which is something I read about and I tried, and it's actually pretty cool, and I'm going to try to do a bit more of it this summer. But it gets very, very long because when you replace your diagonal, you need a lot of extension tubes.
Andrea, sorry to interrupt.
Yeah.
There's one thing to consider when you use a diagonal. There's a lot of torque. And I've had the experience where that thing will just rotate if you don't have it cinched down. So
no, I know. I don't recommend it. I don't like it.
I don't recommend it.
I didn't keep it. But if you go onto YouTube, you'll see a vast number of people doing it that way. And I hated it. So, but it took me a long time to get the right adapter because I had to connect to my refractor directly without a flattener. Then I had to get the right number of extension tubes. Well, just hang on. Let me just show you what I had to do here. Let's go to my next slide. Ooh, why am I not moving forward? Give me a second here. All right, so yeah, so I have, this is the whole imaging train I came up with. I have my filter, the UV-IR cut filter. I have several M48 extension tubes, and they will thread into the base of the Quark. Then you see the Quark is the black piece and the red with the little knob, and the knob is a power, and then you can adjust the wavelength with this little knob. You do need to power the Quark. You need to have it plugged in. Then after the Quark, I had to buy DayStar versions of these adapters, and they got quite expensive. So there was an M42 adapter to do a threaded connection. I ended up buying the 0.5 reducer from a local astronomer in my local group. And I'll tell you why I need a reducer afterwards. But I quite love the reducer, and it was worth it. And I also have a tilt adapter. Because the Quark has a built-in 4.3 times Barlow, you can get Newton's rings, which is an artifact of rings. By tilting your sensor a bit, you can get rid of Newton's rings. I'm not super crazy about the DayStar tilt adapter. I have also in the past used the ZWO ADC, which is an atmospheric dispersion corrector, and it works really well, but I stopped using it because I had dust stuck in it. But I may go back to it. So I'm not crazy about the tilt adapter, but you kind of need it. And then I have the 174 camera for this. For this setup, I like the 174. It works well. So that's the situation. So because a Quark has this built-in Barlow, you really are zoomed in on the sun. Like you're so zoomed in, sometimes you can't, actually I'll go here. That's how zoomed in you get. You can see one sunspot, you're zoomed right in, and it's easy to get lost in the sun. It's hard to figure out which way you're going, which spot you're looking at. Getting the Quark made me take notes and do a lot of sketches of the sun so I could identify what spot I was looking at. And for that reason, the 0.5 reducer is quite nice. And I'm just going back because I think this was a shot with the reducer, and it gives me a wider field of view, and it gives me a little sharper view of the chromosphere. And as you can see, I have quite a nice sharpness on the spicules along the edge. The DayStar Quark comes in three versions, but two main versions, the prominence version and the chromosphere version. The chromosphere version I bought because most people said that you could still get some of the prominences. And as you can see, I do get prominences. I don't think they're quite as sharp and as crisp as I had with the lump. But when I play with the tuning knob, I can, some days are better than others. So you can adjust so that you're tuned more towards the red wings or the blue wings. And that depends whether the prominences are going away from you or coming towards you. So I experiment a bit with that. But it's very close up. So this is, I think this is the spot without a reducer, and I'm going to show you now the spot with the reducer. So this is the same spot with the 0.5 reducer. So it's a much wider field of view. It's a lot easier to be oriented with the edge and what's happening. And in my experience with my telescope, the sampling with the 0.5 reducer is the sharpest. And when I run a really sharp image, I use the reducer. So it seems ridiculous to zoom in with the Barlow and then reduce back out again, but sometimes you have to do it. And then once you get all zoomed in, you get to see lots of exciting features like the flares and prominences. And this was just a cute little flare that I caught one day by accident. Like I said, I do try to, you can get the prominences with the Quark chromosphere. This was a time lapse that I did last summer, and not as sharp on the prominences, but still very dramatic and very glowy. The Quark chromosphere does do the best, I find, with the chromosphere. So all those details. This is a close-up of a very complicated sunspot. I was able to do a time lapse of it, and this is without the reducer, and it's a softer look, and it's kind of glowy and soft, and I quite like that as well. So I got really zoomed in, but you can see at this level, you don't know which way is north, you don't know where anything is happening, so it's very easy to get disoriented when you're zooming around the sun to see what's happening. A downside of the Quark is that you don't have a full disk. So you don't have any sense of the whole sun. And so for me to get a full disk with the Quark, I have to use the reducer. So I first of all use the reducer, and it still is a 12-part mosaic for me. And you got to move really fast. So you got to do the whole top, 2 loops through the middle, and then get the bottom, and try to get it as fast as you can, because otherwise they won't blend well together. I have never tried a mosaic without the reducer. I can't even imagine. I would get lost very quickly. But when you do the mosaic, you can really get so much detail, and it's really quite fascinating. So I quite like this one. That being said, with one thing I did discover, which was really, really fun, in Photoshop, there's something called auto align. So it takes my 12 or 14-part mosaic and it automatically aligns everything. And then there's auto blend, and it automatically blended everything. And so since I discovered that, I like mosaics a lot more. So a quick summary of the software steps that I would take for lucky imaging in H-alpha. I do use a planetary camera. Because they have the USB 3.0. There are some really great cameras out there. The 432 and the Player 1 have even bigger pixels, which I think might also be really nice for solar. I use an external SSD hard drive with my computer when I do the planetary, the solar stuff. I do it for planetary too. The videos take up a huge amount of storage space. Like they just will suck your computer dry. So everything will go to my little hard drive. And with the SSD hard drive, you can get videos to download really, really fast, which is handy for doing your time lapses, or even just trying to do a mosaic where you want to move as fast as possible all around the sun. Now, I mentioned I used to use fire capture, but I do use now Sharp Cap exclusively. And I don't know how many of you, I'm sure many of you know Simon Tang. He's a really well-known and very accomplished solar imager. He has several videos out there where he sets out his system for using Sharp Cap, particularly his technique of using the histogram to capture both the surface and the prominences. And also, and I'm going to talk about this, but he recommends using creating flats, applying flats during acquisition. And that's what I do. And so that's something I'll talk about in a few minutes. The sun is really bright, so you don't need a long exposure. You want super short exposures. Because of seeing, you want to go as short as you possibly can without keeping within 70% of your histogram, and then you're going to stack away the noise. I use auto stacker for stacking, and I do curves for contrast and deconvolution in IMPPG. If you don't do solar, you probably don't know what IMPPG is. It is a solar processing software. It'll allow you to process your solar images. It does, it can do some batch processing. It'll do deconvolution and sharpening, and it can also do auto alignment, which is great for time lapses. It's pretty old and it's a bit glitchy, and there's some new tools that are coming out, which I hope will help. Because we image in black and white, we have to colorize them, and there's different ways to do this, but a quick way of doing this in any software, take your red channel, convert to RGB, raise the red midtones, lower the blue midtones, and you'll get orange. There's a bit of a convention as well in solar imaging that white light are colored yellow, H-alpha images are colored more in the orange. And then I already spoke about creating mosaics with auto align and auto blend. In Photoshop, maybe other programs have similar processes that really makes a big difference. Solar flats, yes. Nobody likes flats, but at least with solar flats, you can take them while you're imaging and apply them while you're imaging. So essentially what you need to do is sort of blur the sky, blur the sun, take flat frames and at a proper exposure, which is 70%, so you see the dust spots. There's different techniques. When I first began, I could just go to a blank spot in the sun, defocus, and then run flats in Sharp Cap. But as we get closer to solar maximum, there are no blank spots on the sun anymore. There's sunspots everywhere, so that didn't work. The second technique is to get a cereal bag, obviously one that's been emptied and clean, and you put it along the top and it fuzzes the sun. But when I got the Quark, it was a little more challenging. The Quark by its nature has, it's not evenly illuminated. There was also, I believe, a light leak, but I was able to eventually find that light leak. So I ended up buying a flat cap, which is a blurry thing. I thought I had my flat cap here, but I don't know where it is. That's a picture of it, nothing fancy, although DayStar did charge me an arm and a leg for it. And I stick it on the front, gain to 0, take your flat, and then you have all your dust stuff is gone. Sharp Cap will apply it live, and then you do your acquisition. So that's pretty cool, and I highly recommend doing that. Some new and exciting image processing tools are also on the way. I don't know how many of you
Andrea, before you...
Oh, yes, sorry.
There's a question John asked about focusing.
Yes, and actually, how do you focus? Simon, in this video, and I'll refer to the video later, he did a video with Chuck's Astrophotography, and he gave a technique for focusing. One of the things he did was he raised the black point, lowered the white point, and went very high contrast. And you focus when you are doing the high contrast. And then in Sharp Cap, there's again, using the histogram to go very high contrast, do your focusing, and then get the histogram. There's an auto histogram function. That's how I focus. Also, Simon's been trying to get me to do autofocus, and I haven't done that yet, but I'm sure there's an autofocus way of doing it. I don't do autofocus for my solar, so I don't know if that answered your question.
Yeah, so you're thinking about getting a focus motor?
Well, I can tell you that I've been doing deep sky for many years, and I just got autofocus for deep sky. So I'm very late to the party, but I do tend to sit next to my telescope and I do manually focus. So that's just the way I do it.
Thank you.
Maybe one day I'll get an autofocuser for the sun, but I haven't gotten one yet. Okay, so I guess I've jumped ahead to new and exciting solar tools. Bill Blancham, I'm sure if you have PixInsight, you know of him. He has developed a whole bunch of PixInsight scripts. Well, he has released recently Solar Toolbox. And this picture is from a video, a very long video, where he goes into great detail on using it. So if you already have PixInsight, this is a free it's just a free download. You can get it installed. You have to have the very latest version of PixInsight to get it to work, but very interesting. So he uses one process in PixInsight. It'll adjust the contrast. You can work on your black point, your midpoint, your white point. It has a deconvolution sharpening. It will colorize. And it has this really cool thing called prominence boost. And I guess it's trying to brighten the prominence without brightening everything. And essentially, it's going to be an alternative to IMPPG for the sharpening and the curves. And I have it, I've been playing with it. I still like IMPPG a little better because I'm used to it, but I think this has great promise. So this is what it looks like in PixInsight. This is an image I took not long ago. And as you can see, the solar toolbox, it has surface and prominence mode. It has prominence only mode, and it has surface only mode. It can do contrast, color, and sharpening. And this black and white image, by the time I was done in Solar Tools, looks something like this. And it's quite different from my normal processing. I think there's something I could do with the edge, but I was quite interested in what happened with the prominence boost, and there's quite a lot of nice sharpening. The toolbox also does the contrast on the surface is quite wild, so that was interesting. So I'm still working my way on how the best to use it. This was an image that I ran through IMPPG and the Solar Toolbox, so it is quite a different look to it, and I'm uncertain which one I like better. So, but if you already have PixInsight, why not do it? It's a lot faster than IMPPG and not as glitchy. So that's pretty cool. The other thing that I'm really excited about trying, and I haven't gotten very far on this road, is solar guiding. Because I do a lot of time lapses, it's really important to try and have all the images be the same place in your small sensor. So I often sit beside my telescope and I manually, recenter things. But this would allow me to use an experimental version of PhD, and PhD is a deep sky guiding piece of software. And it uses a guide camera, which if you do deep sky, you have a guide scope, you have a guide camera. I did one of my little homemade filters for it. I've attached it to my scope, and that's as far as I've gotten. But I'm hopeful. My friends Stefan and Shelley, they use it, and their time lapses are just unbelievably perfect. So I'm really looking forward to that. So that'll be an exciting new thing to work on this summer. And Santa Claus this year brought me a calcium K blocking filter from Lunt. So that was my Christmas present. It is a diagonal. So once again, I thread in the planetary camera. And with this, it's been suggested that I use an aperture mask. So I'm actually stopping down my 100 millimeter scope to 70 millimeters. And I have a second mask which stops it down to 50 millimeters. And this is supposed to help with the seeing issues with calcium. Calcium, the first thing I noticed when I did some calcium K imaging was the seeing was awful. And that's because the calcium line is in the ultraviolet range, which is why we will color the images violet. And it's very affected by seeing. So stopping it down is supposed to help. So I've been experimenting with my different aperture masks, but these are some of my first images. The calcium line, it looks a lot like the white light images, but with a lot more detail and a lot more granulation. So that, all I needed for that actually was the Lunt blocking filter again. And I know everyone's going to be upset that all this heat's in my telescope. Lunt told me I did not need a front-mounted ERF with this. So there you go. That's my calcium stuff. And so that's enough about me. And what I'd like to talk about now are just some of the resources out there if this is something you might like to try. The first resource is the Solar Chat Forum. It's a bulletin board with some extremely experienced and very friendly solar imagers. So I highly recommend you go there. You'll ask questions. You'll learn so much from the expert people who are on that forum. I also completed the Astro League H-alpha Solar Certificate, which was totally fun. It's really good training. You have to watch the sun for 30 days and you have to track sunspots, and they make you sketch or take images of the whole disk. You have to identify different prominences. So it's really good training on just getting to know the sun and getting into the habit of documenting what you're seeing. So I love that. That was really fun. I've mentioned Simon like 100 times. He knows more about this than anybody I know. You can see he has an Instagram account. I suggest you follow it. You'll be very inspired. He did a video with Chuck's Astrophotography and it's a very long video, but I recommend it. It goes all into great detail, how to focus with sharp cap, how to use the histogram with sharp cap. And he's done some more recent videos on the Skywatcher What's Up webcast, and his still using sharp cap, but some of his techniques have been updated. These are images, these are screenshots I take on my cell phone every day that I do solar imaging. So I go to Space Weather Live, the app, and I take a cell phone picture of the sun that day. Remember I told you I always get lost on the sun, so this will help me identify which sunspot I'm looking at, what's happening. It gets me in the habit of orienting my solar images north up, because that's another convention of solar imaging. And the people on the Solar Chat Forum will remind you of that. And then the Gong Network. The Gong Network is a little harder to find. If you Google the sun in H-alpha, you'll come to the Gong Network. And this is a network of about 5 or 6 H-alpha telescopes from all around the world. And so you can always take a look and see what's happening on the sun there. It's like a live view of the sun in H-alpha. So that way you can look and say, hey, I want to look at that prominence in the southeast. And then I match my features to the sunspots and I know what I'm looking at. So every time I go out, I take a cell phone picture of these 2 images, just so I have a record of what was happening that day. Dr. Tamitha Skov, she's also known as Space Weather Woman. She's a solar physicist. She has every week tells you what's happening on the sun, what regions are rotating in, which ones are flare players, which filaments are going to explode. Really interesting. You will learn a lot from her YouTube channel, and you'll be right on top of the whole solar space weather news. And I'm getting near the end. I'm just going to play. This is a little time lapse I did, and I love it very much because it's a close-up of a filament. And I spent much of last summer trying to do a time lapse of filaments because I wanted one to launch. And you can see this is an inverted image. So that white sunspot is actually a dark sunspot. And that little black area is actually next to it is an emerging flux region. The filament in white, this one did not erupt, even though I wanted it to, and it looked pretty loose and loosey-goosey. But the next image that I'm going to show you is actually not, this is not one of my images. It's going to show a filament launch. At the very top, watch the filament there go whoosh. So this is SDO imagery at 304 angstroms. And you can see it's going to launch again. There it goes. So that summer of 2023, there were all kinds of giant filaments on the sun that were launching. And if you look at the same, that's the same filament launch in the Soho LASCO, boof, there it went. These filaments, when they launch, they're launching huge amounts of plasma out from the sun like that. That particular filament went north, but when the filaments come straight towards Earth, you all know what we get aurora. And so by watching the sun and be aware of what's happening, and when filaments are launched or when you have a flare player, you might even get a chance to, you got 2 days notice that there might be aurora. And I'm going to end with, this is a time lapse that I did from Albuquerque. You can, it was the 174 camera with this LUT 40, but the skies were so perfect in Albuquerque that the seeing was unreal. That sun never moved the whole time. And so I was able pretty easily to take a nice time lapse. And you can see how there's a couple of well-placed little filaments that make it look almost like you had reverse Bailey's beads, which is kind of neat. I think that's where Molly lives now in New Mexico. So they have some pretty nice skies. I'll have to go back and visit. I'll have to go back and visit it again.
Yeah, it's been nice. Yeah, we just missed each other. I was house hunting the week after the annular eclipse. I tried to have the two overlap, but I couldn't because of the balloon festival, and I knew I wasn't going to be able to
that's right. We had balloons. I mean, it was ridiculous, all the balloons. All right, so that's the end of my presentation, and I welcome you to send me an email. It looks like my work address, but my work address is my address. I'll take emails, I'll ask questions, and if anybody wants to go down this path and learn about solar imaging, I'm happy to assist. So thank you for having me.
Thanks, Andrea. Yeah, there was a bunch of interesting comments on the chat. You might want to go back and when you watch the video as we posted in a couple days, because some of them apply to you. For example, let's see. Bill Blanchard said, Andrea, I would love to show you more about the solar toolbox. Actually, I'd like to learn more about the solar toolbox. So,
maybe we should
Bill,
get him on the show.
you could show. Yeah, Bill, you should come on to the show sometime.
Yeah, the video that he did is very detailed, and I watch it over and over again because I still haven't figured it all out.
I think that's how we learn PixInsight, all of us. We keep doing it over and over.
Yeah.
Move the video ahead a minute and then go back and try it out.
Oh, I'd love to learn how to do it better because I know there's potential there, but there's a couple of things I'm really stuck on. So.
How do you do your animations?
So I do use IM.
By the way, Andrea, you can stop sharing if you're just going to be visiting with us.
Okay, yes. Let me stop sharing. Okay, good. How do I do the animation? So once again, if you want, there's a Chuck's Astrophotography. He did a very detailed video on this. So what do? So my animations are usually 400 frames every 15 seconds, a minimum of 2 hours. And of course, you batch stack them all in AutoStacker. And then I'll pull up one in IMPPG, I'll process it. I'll save the processing settings, do batch processing in IMPPG. sometimes, and I can do some batch processing in PixInsight, usually if I'm colorizing, and then I'll export it as a JPEG. IMPPG, I have to do batch alignment, and that's the big missing issue. The batch alignment in IMPPG, it's iffy. It sometimes doesn't work. If you have too much motion, you really have to start with a good set of data that's pretty well aligned, and then it'll so that's, to me, that's the black hole. I'd like to do that in PixInsight somehow or somewhere.
Have you tried pip for doing alignment?
No, except
Not work well either.
Yeah, alignment is.
It tends to make everything smaller, pip. But yeah, I sometimes do pip to just do a rough animation to see how messed up my data is.
Yeah,
it's fast and it's quick.
Yeah, double check the settings to make sure that it's not reducing the file size or like the image size, something like that.
I think it's doing something like that.
Settings, and sometimes it's hard to find like that one setting.
Yeah, so basically though, I like to align them in IMPPG if I can. So I just try to, if I keep my sun really, really tight centered, I usually can do it.
I think alignment is something for full disk. I don't want to say it's easy, but it's really more straightforward. But if you have a surface feature and you're zoomed in, alignment comes down to a manual process.
Yeah.
As far as animation, Photoshop will do animations with their timeline functions, but you still have to align everything. And that's what takes more of your time.
Oh, so actually on that point though, is I do tend to, I export to JPEG, and then I will go into Premiere Pro sometimes, because then I can do a cross-dissolve blur, which makes things look a little nicer.
Actually, in Photoshop, if you do a stack and a timeline, you can do a tween.
Yeah, I don't know how to do that.
Oh, it's part of the timeline.
I'll learn.
Yeah, we've got a blending tool in the timeline, or different kind of blending than, yeah.
But all of this is alignment is the key feature.
Yeah. It is. It's a big one.
Yeah.
It's the big one.
If there were a tool that would align surface, I would pay for that one.
I think there's like I was on an AI panel earlier today, and when I was looking around, I think there are some AI alignment things coming out. So that would be a good thing for AI.
Something else to try too is FFT registration in PixInsight, which instead of looking for features, uses the Fourier transform to align the images. And I've had some good success with that for like things like solar eclipse, corona, and stuff like that.
I remember seeing you talk about that, and I remember thinking I must ask Molly what she's talking about.
Yeah, there's a script, FFT registration.
It's a script.
Yeah.
Oh, cool.
And yeah, it'll do whatever kind of image alignment you want, because it's not looking for stars, it's not looking for edges, it's just using the Fourier transform.
Hey, I will. If it's a script, I can find it.
Yeah. It comes with PixInsight. It's not an external script.
There are a lot of solar images that are watching the program. Just to call out one of them, Steve Ibotson. I don't know if I pronounced his name correctly. He has an incredible site on AstroBin. So, Steve, thanks for joining in on that.
Sweet. Is there any other questions or comments that
there are plenty of comments. I don't see any questions.
Yeah, I would like to emphasize a point that I think Eric made. I'm not sure, but for those of you who don't realize it, what we do here on the Astro Imaging channel is invite people to come and make presentations. And if you have some experience and you've got some things going for you, and you feel you have something to offer, please go ahead and contact us at the Astro Imaging channel, and we'll check things out, and we can schedule a program around you. So if you've got something to offer, remember you're part of this program. Okay.
And Bill, that means you. He's already offered to help, Andrea.
You have been called out.
Called out again.
I put the contact us page link on the in the chat and tagged Bill in it earlier. So
By the way, Andrea, at the end of the program, when we end the broadcast, you're welcome to stay and chat.
yes.
And I would say, please stay and chat.
Yeah,
that's-
it will
Thank
look
you.
like we're hanging out, but we actually hang out after the live stream ends.
Yeah.
We're going to carry on, as Tarek would have it.
All right. Well, anything else before we go?
I don't see anything. Alex, you watch.
All righty. All right. Well, thank you so much for joining us. Thanks, Andrea, for your presentation. And come back and join us next week, everyone, to learn how to process your solar eclipse images. Have a good night. Take us out.
Good night, everyone. Patrick?
When we are out.
All right. Shut
Trying
that.
to